Okay, so here we have a question regarding projectile motion. So when you're doing a projectile motion question, just make sure you understand all the key information. Draw out a diagram if you have to. So you've got a vertical tower OA of height h meters, stands with its base A on horizontal ground. Its stone is projected horizontally from the top O of the tower with speed v, and the stone moves in the vertical plane under gravity where acceleration due to gravity is g, all very standard. At time t seconds, its position vector, okay, so where it is in the x and y direction, is shown by vti minus half gt squared j. And the stone hits the ground at a horizontal distance of 4v meters from A. What is the height of the tower? So you have OA. You are projecting horizontally with speed v, and you would expect, you would know that that basically means that it would sort of fall down like this. You're told that any point at time t, the position vector relative to O, so this is our 0, 0, is going to be RT equals VTI minus half GT squared. So really, they're saying that at any point in time, in other words, you're going to be at VT across and negative half GT squared down. And at some point, we hit the ground 4v from A. So this is 4v 0. Well, actually, it's not 0. It's 4v, and, well, considering that the tower was h meters high, you would have gone down h meters. So this is 4v negative h. So they want you to find the height of the tower in terms of g. So in other words, you want to work out how much h is in g. So it's quite simple. You know that this is what you have here. So all you really need to do is sub it in. So we don't know t, I suppose, which means we might need to work that out first. So basically, sub t equals unknown. We want to sub your y equals negative h, solve for t. So in other words, we'll get negative h equals negative half gt squared. So that means t squared will equal 2h over g, or t must equal the square root of 2h over g. We'll go for the positive time. So at this point in time, t equals the square root of 2h over g. And then we just need to sub that into x. So sub x equals 4v, t equals square root 2h over g into, well, x equals vt. So basically, you'll get 4v equals square root 2h over g times v. So v's cancel. You'll get 16 equals 2h over g. So that means h must equal 8g. Just move the g across and the 2 down. And that means C there would be your answer. So in other words, if you're a little bit confused, this I is the horizontal vector. And this, oh, I left out the J. J is your vertical vector. The unit vectors in those areas. So what they're really just saying is that at any point in time t, I'm vt across, vt times I across, and I am, well, negative half gt squared j down. So this is negative half gt squared j, which really is saying In other words, if you don't like vector notation, at time t, the x is vt and y equals -½ gt squared, which is not really anything you don't know either from your projectile motion questions. They've just expressed it in vector form. So if that's confusing to you, well, don't let that confuse you. But really, it's not any different to a normal projectile motion question, except for maybe the way they've presented it. But nothing, you could ignore that if you like, in the sense that your normal projectile motion questions, if you don't like vectors, would have still got you there.
Okay.
And basically, that's how you do the question.
So do you just assume that like the top of the tower is OO, or does it?
We didn't assume that. It specifically told us that the position vector relative to O. So this sets O, O at O. That was not an assumption on our part. And that's a very good question. And that's why you needed to read the question to figure that out. The two common points that would be set would either be O at the top of the tower or A at the bottom of the tower. That's something we very much need to clarify. And the question, by telling you relative to O, tells you that they've set that point as the origin. And that's an important point to recognize.